and insights on IoT solutions for Industry 4.0. Next up, coming up, we have two speakers, Dr. Brent Richards and Dr. Kelvin Ross. First speaker, Dr. Brent, Medical Director of Innovation and Director of Critical Care Research at Gold Coast Hospital and Health Service, and an adjunct professor at Griffin University. Focusing on AI technologies, he is working with universities, enterprises, and the government to unlock the potential AI can bring to healthcare, improving both patient and system outcomes. Second speakers, we have Dr. Kelvin, Chief Technology Officer of Datarwe, which supports a precision medicine data platform for securing sharing medical research data. He is also a director of the Queensland AI Hub, as well as an adjunct associate professor at Griffin University. He has over 30 years of experience in software engineering and enterprise IT applications, having worked on significant projects in healthcare, and he holds a PhD in safety critical system engineering as well. In their talk today, they'll provide an overview of advances in AI/ML research in intensive care and some key features of research data infrastructure that they have built with AWS and Intel to support the growing research community to accelerate adoption to hospital bedside. Furthermore, the talk will be followed by a fireside chat moderated by Ms. Akansha Balani, Regional Alliance Head at Intel. She's leading partnerships with AWS across the APAC and Japan region in the areas of high-performance computing, IoT, and AI. Without further delay, passing the mic over to you guys.
Thank you, Chris, for that kind introduction. I'd like to talk to you today about getting from algorithm to outcome in the intensive care unit, a really important subject that as we move forward. AI, as you know, is considered the fourth industrial revolution, changing everything we do in our work life, in our home life, in our online life. But the reality is, in healthcare, the changes are going to be extraordinary. The era of AI-enabled healthcare transformation has only just started, but it offers great opportunity to us. And we consider it actually one of the big major disruptors that are going to be positive for healthcare, allied to anesthesia, antibiotics, and AI. So the third A of disruption in healthcare. And for us, this change couldn't come quickly enough. We already have considerable data at our fingertips, but we're starting to drown in the data. The data isn't being processed for us, and we're getting further and further away from the patient. So what we actually need is AI-enabled data analysis to help us with our decisions, and also so that it gets us back in front of the patients for more of the time that we're actually with them. In addition, the cost of healthcare is becoming unsustainable. In Australia, 30% of all healthcare dollars are spent on 30% of all government money is spent on health and aged care, and that's predicted to be 50% by 2050. That means we've either got to markedly increase taxes, decrease government spending on other crucial services like schools and roads, or actually put in AI-enabled healthcare so that we can stay within our costs. In addition, AI gives us the opportunity to democratize healthcare. We're finding that in the rural and remote areas that they're missing out on a lot of our fairly straightforward specialist knowledge. And by using AI, we can democratize AI, taking that specialist level services and care to places where they don't currently exist. There are many examples of using artificial intelligence in the world of medicine, and many of it that you may already be aware of. This one where they actually looked at x-rays and showed that for the 14 major diagnoses, they could actually get the AI to recognize the diagnosis on the chest x-ray as good as a cardiothoracic radiologist in America. But they could do it all, 420 chest x-rays in 1.5 minutes. Really important where that level of specialist care is not possible. Now I take you to another example, which is the reading of ECGs. Again, a CNN reading ECGs as good as a cardiologist. And this can be done in real time. It's done with a simple CNN. And although this doesn't matter particularly in front of a cardiologist, it certainly matters where a cardiologist is not available. And so now I'd like to take you to the world of intensive care. Now, when most of you think of the world of intensive care, you think of the picture you see in front of you, the very sickest of patients, very complex and very hard to manage, which they are. Mortality is high. It's 8 to 12% in any intensive care unit, and it's also incredibly expensive. It's at least $6,000 per patient per day in an Australian intensive care unit. However, if you look at this from a separate direction, ICU is paradise if you're a researcher, particularly a data researcher, and therefore also if you're a data scientist. It's a treasure trove of data. Is that there's medical IoT everywhere, capable of being streamed. At the same time, the patient stays in the same place. So all of that data is about a single subject that you can easily see and where all the sensors are attached. The opportunity that sits with us, however, is that much of that data goes to waste. If you look at 99% of the units in the world, all the data that streams across that screen that you see when you go into an intensive care or on every TV show disappears to nowhere. It's not stored, it's not kept, and it's certainly not analyzed past what people see on a screen. It's an incredible waste of available data. And that's just looking at the very simplest of data that we actually have. If you look a little bit further, surrounding the patient, there's a large number of pieces of equipment, most of which are not interfaced, but are able to be interfaced with big streams of data available. And that's just from what we're monitoring on the patient. That's without us looking a little further and monitoring the clinician interaction, the button presses of each of those pieces of equipment. The other big advantage we have in intensive care is that it's a very well-studied environment. The study that's in front of you, which is a large data set of about 1.2 million patients studied over 10 years in Australasia, shows a decrease in sepsis mortality associated with an increase in care. Now, that's amazing to look at in terms of overall care, but it doesn't tell you much about the single patient in front of you. Why? Because this is actually quite a small amount of data. This is only about 50 data points on each patient, and about 40 diagnostic groups are collected, at which stage it's good to get a look at the data, but it shows that we can go a lot further and the opportunities are great. If you take a step further into it, you get into papers like this, which was the True Score. This is where they took data from the MIMIC database, which is more intense, so about every 15 minutes there's data recorded into the MIMIC database. And they predicted the onset of septic shock in the critically ill, sensitivity of 85%, but it was detected a mean of 28 hours before the onset of septic shock in these patients. This is incredible. This is preventative critical care. And 2/3 of that was before the onset of sepsis-related organ dysfunction. So a place we really want to be in critical care. But for most units and most opportunities, we're just not collecting the data. And we can take it a lot further. This was another study, again in sepsis, where they took, again, similar intensity of data and then started to use a fairly straightforward k-means cluster analysis and shows that you could better characterize each of the groups of patients into specific groups, which more related to those patients' outcomes, which makes it easier to better personalize the care of the patient because you've used some fairly standard AI processes. But again, the data is not being collected in most places for this to occur. However, we can go deeper again. So some work that we've done, which is on heart rate variability. Your heart rate is naturally variable, and the sicker you are, the less variable it is. This can really only be measured with a computer. Your heart rate variability predicts the development of an entity called necrotizing enterocolitis in neonates, which is often fatal, and it can be predicted up to 24 hours beforehand. It also predicts mortality in sepsis and emergency departments, and the work that we've done showed that on acquired brain injury, we could almost completely separate survivors from non-survivors of head injury in the first 24 hours and of subarachnoid hemorrhage. Again, this is just with that data alone, and that's without combining it, but it can only be done if you're collecting this data. And you can also discover novel insights into this data. if you, again, attack it properly with artificial intelligence. In this study, they looked at the ECGs and started to predict which of the patients from those ECGs had abnormal cardiac function. Not only did they get around 93% accuracy, in those who had normal cardiac echoes at that time, they predicted whose cardiac echo was going to deteriorate. That's not something that's ever been seen or determined by humans. So again, the ability to actually take that data and take it another step and even start to do that in real time is tantalizing to really get us to individualized, personalized patient care. And here's another example, which is looking at ventilator waveforms. Again, these are the waveforms of a patient breathing on a ventilator. These stay on the ventilator. They don't go anywhere else at this stage, even though there's a port to collect the data. We can look at these waveforms and decide whether the ventilator is adequately synchronizing with the patient to help them breathe. So you can actually do this analysis, but again, it's all happening on the machine only and not being connected through to the other devices. And even more intriguing is that that would be markedly helped by simply putting a camera onto the patient and actually look at how the patient moves, which is how most of us clinicians add to this data. And so another simple stream, a camera, can again markedly improve the accuracy and the utility of an algorithm such as this. And then we move into further steps, which is lung impedance tomography, electrical impedance tomography, which is where you put a very small electrical current through the chest and measure the impedance. And you can actually see the equivalent of the lungs working in front of you at 20 or even 50 hertz. It's an amazing technology, but it really hasn't got very far because it's never been interfaced. And all the presentation is done on screen. And so the interface that the clinicians have is very simple and really very low levels of analytics. And there's lots of opportunity in that space. And so if you look at where the opportunities to use AI lie, they're actually right through what we do. Prediction, natural language processing, image recognition, reinforcement learning along the patient journey is an ideal use of that. And particularly pattern recognition and anomaly detection from these large numbers of biosensors that we've got from the IoT streams, should we move to collect these properly as we have in more units. And if you look at an analogy, the driverless car journey, what have you got? You've got an enormous number of sensors which are being used to take you to your data takes you to actions, which is the journey you're doing, and the goal is to get to your destination as safely as possible. But it's a very individualized journey. If we take the same thing into the precision medicine patient journey, we've actually got, we can use exactly the same rules, same methodologies, and a lot of the same sensors. So take the signals, look at the intervention and actions we need to do, and get a very positive, personalized outcome for the patients that are sitting in front of us. These are the sickest patients where we can make a very big change to what we're doing. So the challenge that we have is that at the top, we've got very large amounts of data based around very large patient numbers, but very small amounts of data per patient. That's across the top. Down the side, you've actually got occasional units like we have at the Gold Coast, where we're collecting a huge amount of data, but on a small number of patients. The challenge that I put to the industry is that we need to close this gap to improve our patient care and outcomes. We need to use the cloud and medical IoT to fill this gap and improve the care and outcomes that we deliver to these patients. And this is the challenge I'd like to put to Dr. Kelvin Ross, our next speaker. So Dr. Kelvin Ross, I'd like to introduce, who's from Datarwe and who's certainly helping the Gold Coast University Hospital on this endeavour. Thank you.
I'm Kelvin Ross, CTO of Datarwe. In this talk, I'll explain the technology behind the ICU data platform supporting the linked time series, streaming and IoT data collected during a patient's ICU stay. Key to the AI advances integrating IoT that Brent discussed is first developing a high-fidelity digital twin that we can develop and deploy models. Here we combine the electronic medical records containing observations, lab results, drug infusions, etc., and link it to the high-frequency data to make sense of it. Our first hospital, we have about 16,000 archived patient stays over 6 years, And in the last 12 months, we've connected all 240 Hz ECG, blood pressure, SpO2 data to the medical records. This has accumulated about 2,000 patient stays of ECG per annum, which collects about 140,000 hours of 240 Hz data. We are now proceeding to link this in with 13 other ICU units across Queensland as part of a partnership with Queensland Health. The gold standard for ICU data research is the MIMIC dataset, which has over 60,000 episodes from Boston. Our plans are to make available a more extensive platform to global researchers that extends the data deeper to high-fidelity linked IoT data and includes broader patient participation across multiple hospital ICUs. As Brent mentioned, very few hospitals retain any linked archive of their device data for later inference. There are still many IoT feeds beyond the bedside monitors to link to the patient medical record for a more comprehensive feed of continuous patient observations. We also have ventilators, dialysis machines, cranial pressure monitors, etc. to be included. We also envisage a future ICU that integrates devices for streaming video and audio for continuous patient observation. In the ICU ward, most of these devices don't have IoT constraints such as limited power, network and storage. However, innovations in implantables and wearables that will be integrated in the ICU ward will also require further integration, and these IoT constraints have to be factored into the platform architecture. Deploying models in the ICU environment requires a hybrid architecture across edge, node and cloud to integrate feeds and inferred events. For instance, to provide more accurate alarm of cardiac arrest, our model may incorporate patient state from the electronic medical record, along with arrhythmia changes inferred from the monitor data retrieved from the node. However, as alarm fatigue is a major issue in care, further suppression of false alarms may incorporate inference from embeddings from edge-based cameras indicating patient status. So across this hybrid architecture, extracting data, building and deploying versions of models and validating monitoring results leverages many aspects of the AWS and Intel technology stacks, such as we use S3 and Kinesis around our data storage and event processing, for edge deployment and edge support, platforms such as Greengrass, ECS Anywhere, and then ultimately looking at outposts for hospital deployments is quite important. In model development, we make extensive use of SageMaker pipelines, but also looking at how Habana and these other platforms from Intel can really reduce our training and inference costs, and then using OpenVINO to look at how we might also reduce and deploy our models. A big part of our work are the labeling platform pipelines, and here we make extensive use of SageMaker pipelines. We also plug those into using ECS containers, using smaller lambdas, and also a lot of use of Athena, which we might discuss. But also how we're looking at how that inference through these pipelines might leverage things like C5 container optimization, again, to improve performance and reduce costs. So at a fundamental level, we're developing, deploying, maintaining models at the edge node and cloud level. And that requires workflows that support key aspects of the AI model lifecycle. The final goal is to have effective AI models that process input data and then output events or data labels that get written to data stores to initiate further actions. However, in supporting this, we require workflows that collect data, iteratively evolve the models, deploy them to devices, and then analyze performance. So for IoT, management of these layers is key to success. Data, unfortunately, that we collect in its raw form from our IoT workflows requires significant refinement to ready it for research and AI model building. In medical domains, data typically requires anonymization and de-identification. It typically requires restructuring into other formats and linked with other data sets. Data needs to be cleaned and missing data imputed. And a significant part of our work is labeling data to guide model training and validation. Consequently, we find data management is the largest portion of developing AI models, across our medical research domain. Our experience is consistent with other studies that show that this is in the order of 80% of the effort. As this effort is required by all our research collaborators, this is a significant focus of our work on how we can reuse data preparation and amortize this cost across research projects and collaborators, thereby reducing their costs. Effectively investing in the data infrastructure to support multiple research projects is the goal of our effort. In particular, for the data infrastructure, we have established data ops pipelines built on the AWS Intel stack. Data is ingested from the electronic medical records and the IoT feeds into an S3 data lake, predominantly in a Parquet format. Data enrichment pipelines are built using a combination of Lambdas, SageMaker pipelines using container components, and Athena. In this area, we have found Athena to be an amazing big data querying workhorse. It's extremely scalable and it's very cost effective. We take inspiration from the Tesla data engine approach to build our own Datarwe data engine. I highly recommend you check out the work of Andre Carpathy's AI team as the state-of-the-art in deriving reliable AI/ML insights from streaming device data. You'll see at the bottom of this slide I have included some links to relevant talks that you should check out. In our Datarwe data engine, we've extended the concept of the data hierarchy as a single cycle to consider the enrichment process as iteratively building a label store over many cycles of annotation. Starting with the raw ingested data, initial models are constructed using feature engineering and human labels. These models can in turn be used to annotate and extend the label store with human in the loop and active learning processes. Our label store also contains annotations derived from multiple versions of models or model variants, which has provenance recorded in the label store. Effectively, we have an ensemble of annotations in the label store that we can derive highly accurate insights across the raw data. Models may be further optimized and quantized for efficient execution and validated against other model variants in the label store. Models that can then be selected for deployment into production. Deployed model outputs can then be ingested back into the data engine for subsequent validation. So this provides this end-to-end cycle where we can collect data from our IoT data streams and really build a framework for validating and analyzing performance and then improving performance in the future. We have found integration of semi-automated labeling is the key to building comprehensive label store and more accurate models. We have used SageMaker ground truth with various custom templates to integrate human labels, but we incorporate both active learning and pre-annotation using earlier model variants. Essentially, human experts are correcting the pre-annotations, which is more efficient than labeling from scratch, and active learning techniques help identify which human validation will help our models discriminate more quickly. These processes are key to integration of clinical knowledge that Brent discussed. It marks the collaboration between humans and machine learning to encapsulate clinical interpretation. Typically, labeling tasks require various levels of clinical skill. Some tasks are generic, such as tagging data as personal health identifiers and as used in validating and improving our de-identification tools. Alternatively, ECG arrhythmia labeling requires more clinical expertise. We split the generation of training data using medical students and nurses, but our gold test set used in validation is labeled by more experienced cardiologists. The Datarwe data engine incrementally extends knowledge as projects augment the label store for subsequent projects, and reuse of prior data preparation will reduce significantly from the 80% effort burden for model development. Key to advancing ICU care is using AI will be marking more real patient data from more hospitals, more accessible to more researchers. Conversely, researchers can contribute back into the platform through model sharing and transfer learning and adding more accurate enrichment and annotation in the label store. I've provided here in this talk a quick high-level summary of the key aspects of the Datarwe data engine and how we're using it to drive AI insights, particularly for the high-frequency IoT streams within ICU. We're extremely grateful to the support from AWS and Intel, who are crucial partners in implementing these platforms. Thank you.
Thank you so much, Dr. Brent, for that insightful session. I think it would be amazing to now get the experts together and have a quick chat about the journey and have a chance for the audiences to also interact and ask questions with all of us. My first question would be both to you, Dr. Brent, as well as Kelvin. How did you start your journey with Datarwe, AWS, and Intel, and why?
Yeah, well, the journey was actually quite interesting. I mean, Kelvin and I initially met at a startup weekend and didn't know each other at all, but seemed to gel and seemed to have a common interest in data. And along the journey of that, Kelvin recognized that I was playing in the data, and I was actually literally plugging laptops into the back of monitors to pull data off them. And Kelvin said, but there's a much easier way to do it, which I had no idea about. And he could see the value in the data. And he could see that the data itself was going to be very valuable and useful. And that starting to move it into a scale environment was going to markedly improve what we could achieve with it. And so really that's where the technology partnership began. And that's a critical success factor to any of this, is that you've got a technology partnership and a mutual and shared agreement and understanding to move forward, to solve a combination of a problem we're solving and to use the cutting edge technology to actually make it work.
Yeah, I think it was interesting that, having come from other disciplines like the military with avionics systems and high-speed trading systems where you're used to dealing with large volumes of events and flows, and obviously, Intel and AWS are prevalent in those sectors, working in the medical space to really think about, seeing those gaps about how IoT and sort of high-frequency data is processed. And, it was sort of applying those technologies in those fields where it hasn't been applied as much, we found, within the hospital systems.
Yeah, and look, just to add a little bit more to that, is that intensivists and researchers are always trying to improve outcomes. And there's always been sitting in the back of my head and many of my colleagues that we can do something better, that we can do it with data, but we've never actually had access to the likes of AWS and Intel to get us to that space. And to partner with Datarwe to get us to that space is actually catapulting us into a whole new world, a world we've always wanted to be in, but we've never actually known how.
And I know that Intel and AWS really appreciate the partnership that we've got with Datarwe as well as Gold Coast University. So thank you so much, guys, for that. The next question would be, again, to the both of you. What do you think is the most interesting challenge for healthcare and research right now?
Again, I'll kick off with that. I think that healthcare at the moment is struggling to understand the knowledge base inside healthcare as to what is possible in this space is just not there for many sectors. And in healthcare, everything is considered urgent and important. And this is actually, you've got to look at the horizon to see what's possible. And so the internal knowledge base about this is remarkably small. And so I think one of the big challenges is to actually move that knowledge base along, to get it there so that we can actually start to extract the value from the data. Again, we're running out of money, as I said earlier in the talk, for healthcare. And yet we've got this huge asset, which is called data. And it's that data that we actually need to use and the AI that goes with it that's really going to improve the patient outcomes as well as the outcomes for the system as we move along. I think that they're the big challenges in actually making those two places work together, which is actually leveraging everything we can get from the IoT and the AI and focusing that on patient outcomes is a journey that healthcare is still very early in its very early along the path.
Yeah, thinking about it from a technology point of view, you're seeing a lot of research and development going on in AI and other spaces in the medical area, but it's not yet translated really into the hospital and to the patient bedside. And part of that is sort of historically, there's still a lot of legacy of siloed applications, devices that run separately. And really it's this future of really integrating in things together. And really, I think it's now hospitals modernizing their architecture to create these integrated communicating, collaborating systems. And I think that's going to be the key to collect that, and then how we can translate the research into the real world practice and then get feedback that that's working correctly.
Yeah, I think absolutely application and having the experts like yourselves really building that bridge between healthcare research with technology has really transformed the way in which you can really drive adoption at this rate and at scale. Another question to the both of you would be, what are the key business challenges you need to address to maximize benefit for IoT as well as AI/ML?
From my perspective, probably the biggest mindset change that needs to happen in health is that data needs to be seen as an asset, not as a cost. Up to this point in time, we've struggled to collect the data. It's been considered a very expensive thing to do. Only a small amount of data has been collected, and the secondary use of that data has been minimal. And yet, there are many businesses outside of health who work on literally giving the services away free purely to get access to the data. And a lot of the data collection has been based around the simplest of human-based collections. And most of our opportunity is actually sitting there in the machines that we're interacting with. I put up a slide previously with an infusion pump if someone's getting an infusion of drugs. People are not collecting the key presses from that. Now, that's really simple data. That's like mouse clicks. And that's going to tell you so much about what that user interface is like. And yet it's not being collected. It's not being used. It's not being used as a quality piece. And so a really big piece that we need to do is to get people to understand there is huge value in that data. However, there's one thing to be careful of in that space is as people start this journey, they have this belief that almost magically you just make this data appear and you don't have to do anything with it, just the data's just suddenly there. And then you employ a single data scientist and apply a bit of data science magic. And suddenly you've got benefits and outcomes. Now in the data science world, we well know that doesn't work. You've actually got to collect your data, clean your data, continue to add tools to the data and work on that. Okay? And that, again, it's a team-based approach at that point. And that getting the outcomes is actually going to be a continuously fed process where you've got to keep feeding more data. You've actually got to keep improving the data. You've got to keep improving it and working with the algorithms. And at the same time is that introducing that into the clinical practice will actually change how people work, at which stage it will change the data. So you've got to come back and retune it. So there's a lot in terms of the maturity of the journey that's going to be a big challenge because most healthcare facilities haven't started that journey, let alone started along the maturity path.
Yeah, Brent makes really good points there. And the obvious business challenge is, will this deliver value to the patient, but also can it do that without really blowing out our healthcare costs, which are already under significant pressure? So for researchers and product developers, it's that aim to lower the healthcare costs with better outcomes, and that's a big business challenge. But it's interesting in doing that in the environment we work in. The business challenge is also how do we meet those assurances to the health system and the hospitals and the patients around privacy and that the algorithm's accurate and continually improves. And I think as the regulator also gets more involved here about how devices and diagnostics are used in the workflow, your challenge is going to be about how you meet that regulatory requirement to sort of develop and sell your product within that network. So I think here, a key, more open environment for collaboration between the hospitals as customers with their suppliers that are doing R&D on products that are going to be deployed there is going to be a key factor moving into the future.
Absolutely. And I also do feel that building replicable solutions that could be applied into multiple segments within healthcare and then helping to drive that as implementation is also going to be very key and a good focus for the people in this industry. The last question I have for the both of you is, how have you led your organization through this transformation? What are some of your key learnings that you could share with the audiences that are embarking on a similar journey?
Okay. So again, it's, as Kelvin pointed out previously, there's a lot around education. Is that most people don't know what they don't know. And yeah, that might even be inside the IT departments themselves, is that they're so busy with doing business as usual. This, as a new way of doing business, is not a common path for them. And so there's a lot in that space. Secondly, it's a matter of getting people to understand and believe that this is possible. But that it does take time and it does take effort. But at the same time, it's not the same amount of time that it used to take. Is that what used to be a very long serial process, which might spread across years from an idea through a translation to practice, can be broken into weeks and months if you do it well. Because if you're getting data and feeding back algorithms, that loop can be closed very quickly and you can learn and understand. I would certainly tell people that you start small and start simple. Most people want to boil the ocean when they first start in AI, and they want to do the ultimate cutting edge algorithm on the ultimate, and it's a process that would take years. You go, no, start small, start simple, start where you know you've got some data that's reasonably clean to start with, and just start to demonstrate value. I'd also suggest that you choose something where you can demonstrate value fairly easily, because that will start to bring people along the journey. So you need to be very realistic with what you're going to achieve. I mean, for some projects, which I was going to do around natural language processing, I said, I'm looking at doing 30% of what's in front of me. Not 100%, just 30%. Now, I think it'll be 50% as we move along. Okay, but just, shall we say, it's the standard under promise and over deliver. And then getting people used to the concept that this is going to be a team-based journey, is that this is not a single-spirited individual, a couple of individuals. It needs top-end buy-in, and it needs all the members of the team working together to make this work.
Yeah, I'd echo Brent's points a lot there as well. And I think, what Brent works on a lot is making sure that we're educating the clinicians about what value can be provided, but also what can be achieved realistically. And that's really important to then feed back into the technology team, because I often say as technologists, we've got a hammer, we just don't know what nut to crack. So a key element is educating the clinicians and the business as key parts of the team to drive the outcomes. But I'm also finding that we're having to do a lot of education on the technology front as well. Within the hospital environment, we're typically dealing with people who are really dealing with a lot of legacy applications and things like that, and aren't exposed to some of the newer technologies, newer platforms. So there's a lot of education about what the impact of that is like. And like Brent said, about starting small, typically in these large organizations like hospitals and health systems, people feel like, oh, we've got to get all the building blocks right. And they'll spend years sort of, establishing data dictionaries and flows and things like that. But they don't really know what the end goal is. So a big focus of what are these spikes that you want to establish for small goals that are more, what's the end use case and what do we need to drag together to connect things, to get that architecture connected and right, because in exposing that, they'll find other things that are important or not important. And so I think it's really key for organizations to start out on those small POCs to sort of educate themselves and to start understanding the components within their infrastructure that are capable and those that need to be extended and improved.
Absolutely. I definitely feel that making sure that you understand and identify the use cases that are achievable and being able to build for your business with IoT and AI with partners such as yourselves is really going to be the way that can get them to the next level really quickly. Thank you so much, Dr. Brent and Dr. Kelvin. It was a fantastic conversation. I hope the audience has learned quite a bit. We can sum up that technologies like IoT and AI are really transforming every industry as we know it today, as long as you in the business world or in the research world know how to really articulate and extract the goodness of the data that you have. With the technology, you can drive to adopt it. So with that, we end the session today. Thank you everyone for listening. Thank you again, Dr. Kelvin and Dr. Brent, for being here with us.
Thank you for inviting us.
Hello, everyone again.
Okay. Hi. Thanks once again. Thanks again, all the speakers, right? So for sharing your insights on IoT applications and in environment two industries, manufacturing and healthcare, right? So I think we do have some time for Q&A, and we have some questions coming in. So I'm going to direct them to relevant speakers. Okay, so I think the first one that we have is I think one attendee is interested in some examples of IoT analytics services and functionalities, right? So maybe I'll direct this to Aditi. Maybe you can share more about this.
Sure. So for IoT analytics, so first of all, AWS has a complete portfolio of analytics services, namely services like Amazon Kinesis Data Analytics, Data Streams, Amazon Elastic MapReduce, Amazon Glue. But specifically talking of the IoT analytics is a service which helps you to collect, process, store and analyze your data. And you basically IoT analytics is specifically designed for device data. So you are talking of custom use cases where you get some pre-built machine learning templates like for predictive maintenance, or if you're talking of things like proactively replenishing your supplies in when you're talking of the industrial use cases, or you're talking of the process efficiency scoring. So all these kind of use cases where you have to use your data to drive some kind of result and add machine learning model to it, IoT analytics plays an excellent role there. So does that answer the question? If there are follow-up questions, we could take on that, on those.
Sure. Yeah. So good to know that there's a diverse functionality and features, right, for IoT analytics that users can explore. Okay, maybe I go to the next one. I think this next question is on device compatibility, right? So it says, can you like comment a bit on the compatibility of edge devices with AWS IoT services?
Okay, sure. So yes, I did cover that a bit in the session, if you recall the device part. So what we have essentially is we are three different services that we are looking from the device compatibility side. I spoke about Greengrass at length. There is FreeRTOS and there is IoT SDK as well. But I would also like to bring your attention to the partner device catalog, which we have. So often customers come to us, and probably that's where the question is coming from, that often customers come to us to understand what are the devices that we could use, which are probably already there in the market, which is more like qualified hardware that already works with the AWS services, which helps them to quickly build and quickly deliver the IoT solution that customers are targeting. So we very much have a AWS partner device catalog, which is listed. So maybe I could share the link for that in the chat, and as well as if you just do a search online, you would easily be able to find the AWS partner device catalog, which comes with those pre-existing integration with AWS services.
Sure. Yeah, it's good to know that there's a catalog, right, for all these devices, and I'm sure there's many devices coming out, and the catalog will be kind of like updated, right, on a continual basis as well, right? Okay, good to know. So last question we have for today is, how will you manage data security and access with IoT services at AWS?
Okay. Maybe I'm just sending the link. I've just shared the link. Can someone please help to share? Okay, about security. Yeah, that's a good question as well, and fairly commonly asked. So there are multiple aspects of security when we are talking of security in cloud, especially for IoT devices. So one, on the device itself, we are using the X509 certificates, which are basically giving and exchanging policies and providing the ownership for the device, helping in authentication as well as authorization. We also have, for the device security itself, we also have the service which is called the AWS IoT Device Defender, which is essentially continuously auditing your IoT device configurations to ensure that they aren't really deviating from the identified security best practices. Then looking at another level, when we are talking of end-to-end security in AWS, you're not just talking of the device level, you're talking of the security during the communication, you're talking of the security in the cloud. You also want to see what is the roles and authorization or authentication mechanisms for devices accessing certain workloads or certain portion of the workload or certain portion of IoT solution. So for that, we integrate all these services with what we call as the AWS Identity and Access Management, popularly known as IAM. So which has those groups and roles and users and policies, which again further identifies that what is the what are the acceptable policies for the users to or the devices to connect, or actions that are allowed. So it's again a vast topic there, but lots of information which is available on the AWS IoT website as well. The crux of the matter that I wanted to say was that we have thought of security that is job zero in Amazon, and that comes everywhere from device to connectivity to your connectivity in cloud, your application in cloud, as well as the IoT applications which are being used by the end users. So it's end-to-end security which is integrated underlying with IAM.
Sure. Yeah, thank you, LTT, right? So it's good to know that there's features for kind of like managing access, right, by user, and at the same time auditing some of the IoT kind of like operations as well, right? So I think some of these questions, they are very relevant for people in the IoT space, right? Whether it's compatibility and security, that will apply to other users as well. Yeah, I think we are just in time, right? So yeah, just in time we finished the questions. Yeah, so as we have come to the end of today's webinar, right? So so attendees today, you probably get a follow-up email, right? And if you have any further questions, or if you'd like to explore any AWS services further in depth, right, we can follow up from there. So once again, thanks so much everyone for attending this webinar. Thanks again to speakers, right, for sharing your insights. So we do have an upcoming session, I think in September, right? Stay tuned for that. That'll be focused more on AI in healthcare. So thank you, everyone. Okay, take care. Goodbye.
Thank you, everyone. Bye-bye.